Hi friends, welcome to our class. Today's class we are going to learn about queuing theory, a problem which is related to queuing theory. Okay, so last class we came to know about the importance of queuing theory. We came to know about a customer. We came to know about a queue line. Like that, we learned few things about queuing theory. Okay, so last class we learned one problem about this queuing theory. Same way, with today's class, we'll learn how to solve a problem for a given in a queuing theory. Okay, right. So here, this is we are having this problem. Just first see each and every class. I am saying the same thing. We have to understand the problem carefully. Okay, so once we understand the problem, what is the exact data is given in that problem, then it will be easy for us for solving the solution. Okay, so let us start today's problem, right? So here, this is the problem. Okay, I'll read it. In a supermarket, the average arrival rate of customer is 10 every 30 minutes following poison process. The average time taken by a cashier to list and calculate the customer's purchase is 2.5 minutes following exponential distribution. What is the probability that the queue length exceeds 6? What is the expected time spent by a customer in the system? Okay. So here the speciality of this queuing theory problem, you will be getting a paragraph, right? In this paragraph, the data is presented here. So we have to understand what is the exact meaning of this question, right? See, if you are not able to understand in a single stroke, right? So it's better you go for twice and it's better you go for thrice in reading this problem, right? So it is a meaningful problem. Okay, you should understand carefully, then only we can go for solution. Because once we, why I'm saying all these things, because once we understand the problem perfectly, so solution we can save a lot of time in solution, right? So yes, first we will see what are the data he has given here. See, in a supermarket, the average arrival rate of customer is 10 every 30 minutes. Means up to here, what we have to understand, the problem is related to a supermarket. In this supermarket, for every 30 minutes, the average arrival rate of a customer is 10. Means for 30 minutes, the average customers are coming and purchasing are 10. Like that we have to understand. Next, the average time taken by a cashier. Yeah, here we have to understand about this cashier. We know what is the role of a cashier. So, what is the time taken by a cashier to list and calculate the customer's purchase is 2.5 minutes. So, the time taken by the cashier is 2.5 minutes. He is taking this time for listing and calculating the customer's purchase, right? So he has to count the items, he has to make the bill, and he has to take the cash. And we know nowadays cash, the billing is very easy for him. Either it is cash or through this online mode, or through this debit cards, ATM cards, credit cards. Okay, yeah. So how much time he is taking? 2.5 minutes he is taking for each customer, right? So up to this we have to understand what he is asking. Now what we have to show learning this data is what is the probability that the queue length exceeds 6 here. right? If the queue length exceeds 6 means what we have to understand here, queue length exceeds 6 means this is this is giving the information about the size of the queue, right? The size of the queue is 6. Next, what we have to show is what is the expected time spent by a customer in the system, right? So in the system means in the supermarket, what is the expected time spent by a customer in the system, right? Now this is the problem, right? I think all of you understood what is the exact data given in this problem. Now we will move for the solution. Okay, see, yesterday class also we have seen the solution in very easy manner. Same way today's class also we will continue like that. Okay, yes. So first what we have to write, what is the first step for solving the solution is we have to write mean arrival rate. Okay, we will start with this mean arrival mean arrival rate, right? Mean arrival rate is this lambda. Okay, so what is the mean arrival rate? So the customer is 10 for every 30 minutes, right? So lambda is 10 by 30 per minute. Okay, per minute, right? Mean arrival rate lambda is 10 by 30 per minute. Next, after mean arrival rate, we have to know mean service rate. See, like that you have to write mean service rate, right? Mean service rate, we know that is mu. Okay, so what is the service time the cashier is taking here? 2.5 minutes for each customer. Like that we have to understand, and we have to write mean service rate mu is, right? So what is the mu here? 1 by 2.5 per minute. See, these things you have to write exactly. Okay, next, after writing these things we have to go for yesterday we have seen utilization factor. Okay, utilization factor. Okay, utilization factor. So what is the utilization factor? Rho is the utilization factor, right? Rho is what we know. Rho is mean arrival rate by mean service rate. So this lambda by mu is this rho. Okay, this is rho. So lambda by mu, mean arrival rate by mean service rate. So we know this is 1 by 3 by mu is 1 by 2.5. Okay, so we'll get around, after calculating, 0.833. Okay, yeah, so half of the solution we have completed. Next, see, listen here. After knowing this mean arrival rate and mean service rate, utilization factor, okay, so we half of the solution part is completed. Next thing is we have to calculate what he is asking, probability that the queue length exceeds 6. Okay, probability that the queue length exceeds 6 means what we have to write here, the probability of queue size is greater than 6. Okay, the probability of the queue size is greater than 6. So we have to write here, I am writing here, see, first one, the probability of queue size is greater than 6 means queue size is greater than 6 means how we are writing this is rho to the power 6, right? That is equal to rho to the power 6. So what is the rho utilization factor? We have calculated 0.833, okay, to the power 6. So we'll get around some 0.3348 like that. Okay, so this we have calculated, right? What is the probability that q length exceeds 6? This we have calculated, right? Next part of the question, what is the expected time spent by a customer in the system, right? Expected time is, we know expected time is, it is ws, okay? Ws is the expected time spent by a customer in the system, right? So what is ws is ls by lambda. Okay, we know what is ls. So ls is rho by 1 minus rho by this lambda. Okay, so these values, putting these values, we know what is the value of this rho. Okay, putting these values, we know what is the value of this lambda. Now we can write this step as 0.833 by 1 minus 0.833, okay, into 3. So after calculating this, we'll get around 14.96 minutes. Okay, so what is the expected time spent by a customer in the system is 14.96 minutes. And what is the probability that the queue length exceeds 6 means this is the probability. Okay, now this is the probability. Okay, so I think this is the easiest way to solve the problem which is falling under this queuing theory. Okay, so the thing is, we have to understand the question properly. Right after understanding, we have to identify what is the mean arrival rate, what is the mean service rate, next utilization factor. So these are the common things we have to show in this solution part, and later we have to know move to the what is the exact question we have to give the answer. Okay student, okay friends, I think all of you understood this problem. If you are having any doubts, you can ask in the comments. I'll give you the reply. Okay, so all of you, please subscribe our channel. Please like and share our channel. Thank you for watching. Thank you very much.